Hello, my name is Julianna Cofinas from the School of Environmental and Sustainability Sciences, and I am presenting a comparative assessment of the characteristics of Manasquan Reservoir wetland soils and trail soils. The Manasquan Reservoir is a man-made reservoir that was constructed in 1990, which consists of multiple trails around the pine oak forest and freshwater wetlands that were created after construction and are off-limits to the public. Due to the lack of physical barriers and clear signage, pedestrians walk through the wetland areas with their dogs and fish in the water. The objective of the study was to compare the characteristics of soil from the constructed wetlands and soil collected from nearby trail points. The soils around the wetlands of the Manasquan Reservoir will have a larger variety of vegetation, consistent pH levels, and a higher clay percentage than soils found next to the perimeter trail. Wetland soils will have depleted or deficient nitrogen levels, while trail soils will have sufficient or surplus nutrients from stormwater runoff. As shown on the map, 3 soil samples from random points along wetlands 3, 4, and 5 were taken along with 3 points from the 5-mile perimeter trail. The trail points were selected using a random number generator ranging from 0.1 to 5.0. 12 soil samples were collected using a soil probe and put into separate labeled Ziploc bags. At each site, the soil series was recorded according to the soil web data, along with visible tree and shrub species and specific coordinates of the sample location. Each sample was individually pH tested and sieved for texture. Distilled water and glass jars were used to properly nutrient test the soil with a rapid test soil test kit. The wetland and trail soils show similar pH values with an average of about 6. A custom soil resource report by SoilWeb was conducted for an area which shows the pH that should have been found for the area based on the soil type. The areas that the wetland and trail samples came from should be either extremely acidic or very strongly acidic. After testing, all soil samples ranged from strongly acidic to slightly acidic. The texture of each sample was assessed using a soil sieve and weighing each pan after completion to find the percentage of sand, silt, and clay. As shown on the table, the wetlands have a variety of soil textures, including sandy loam, loamy sand, and sandy clay loam, while the trails only had sandy loam. The clay percentage for each texture shown next to the table, with sandy clay loam having the highest percentage of clay. Plant species were also recorded around the general vicinity of each site. Graphs are shown for the nitrogen and phosphorus results of the soil samples from the rapid test kit, which produces a color that represents different levels of nutrient content in the soil water ranging from 0 to 4, with 0 being depleted, 1 deficient, 2 adequate, 3 sufficient, and 4 surplus. Nitrogen was not detected in any of the samples and was therefore depleted. The soil phosphorus values are shown on the next graph and indicate higher average phosphorus levels in trail samples. The soil potassium values follow the same 0 to 4 scale and show higher average potassium levels in wetland soil than trail soil, with the majority of wetland samples showing a surplus of potassium. Each characteristic of the soil was tested for helps build an overall assessment of the wetland soils versus the trail soils. The lack of high acidity could be attributed to rainwater or snow meltwater moving through the soil recently. The presence of sandy clay loam in wetland 5 indicates the soil has a higher capacity for holding water due to the high clay content. The wetlands show a richer diversity in plant species, including oak trees, moss, and greenbrier, while the trails only had grass. While no nitrogen was found in any of the soil samples, this was expected due to nitrogen's rapid conversion to nitrate as it is taken up through plant roots. The high phosphorus content in trail soil indicates excess nutrients from stormwater runoff or even dog waste. The high potassium levels in wetland samples could have been due to shallow samples, seasonal fluctuations, or leached potassium after rainfall. Overall, this assessment analyzed characteristics of wetland soils that showed themselves to be different from trail soils. Further research of the reservoir's construction plans and history, along with continued nutrient and pH testing of the wetland soil, is required for a deeper analysis of the health of the wetlands. Thank you for listening.